Good morning, Algebra 2. We're moving on to lesson 6.3, and we are doing sums of radicals. And notice we also have differences, because when I take the sum, it's the same thing as adding a negative. Would also be a sum. Our essential question is, can you simplify expressions involving sums of radicals? So just a reminder, sums is adding. Radicals are square roots. And if we look at example 1, we're going to see that we are adding a bunch of different square roots. So the first thing I want to remind you is you can only add like radicals, which makes sense because we're used to only being able to add x's and x squares and y's. So like terms, these are kind of the same thing, like radicals. So let's go ahead and look at example 1. Example 1 says 2 root 50 minus the square root of 245 plus 3 times the square root of 125. Well, 50 could break down to be 25 and 2. We've had to memorize our perfect squares and cubes, and this is why. Is because I know that 25, the perfect square of 25 is 5. So 2 times 5 is 10 root 2. Moving on to the next one. Sometimes you may struggle finding a perfect square. In this case, I know it's 49 times 5. So you can always do your prime factorization. And if you did that, you would see that it's 7 times 5. And this would be kind of the same way. I have 2 7s, or I know the square root of 49 is 7 root 5. So remember, you're going to take out the 7 because that's the perfect square, and you're going to keep the root 5 underneath the radical. Moving on. The square root of 25, I know, is 5 times 25. Again, you can go ahead and put 5 cubed. I know the square root of 25 is 5. 3 times 5 is 15, and the root 5 stands alone. Now, we do have to add like terms, and we're going to add them all together. When I do that, I can only add like terms, so I have 8 root 5 plus 10 root 2. All right, moving on to the next example. In this case, we do have to distribute, so notice that this negative 4 root 6 can distribute to here and to here. I knew there was something else on here. There we go. All right, so we can only multiply things that are alike, so that notice that this negative 4 can multiply with 3 to give me negative 12, and root 6 and root 2 is root 12. We'll break that one down in a minute. Minus, oh wait, a negative 4 times a negative 5 is a positive 20, and root 6 and root 3 is root 18, plus 5 root 48. So here we have it. Let's break down what we could break down. I can break down 12 to be 4 and 3. The perfect square of 4 is 2, so this is negative 24 root 3. Plus, I can break down 18 to be 9 and 2. Love it when they give us the easy ones. So I know that this is plus 60 root 2. And be careful with 48. I actually see this one a lot. 48 is 16 and 3. Now some of you might have broken that down as 4 and 12. But remember, 12 has another 4 in it, so you have to break it down all the way. And keep breaking down if that's what you got to do. So I know the perfect square of 16 is 4, and this is going to be 20 root 3. So now we can only add the like terms. So when I add a negative 24 root 3 and a 20 root 3, I have negative 4 root 3. And this stands alone as positive 60 root 2. So the answer is negative 4 root 3 plus 60 root 2. Let's look at this last one, and let's star circle highlight this. This is just something we forget. I actually forget to do this all the time. Okay, notice this root 8. Let me read it first. 3 root 40 plus 2 root 24 all over root 8 minus, I think that's just the end, root 5. Notice this root 8 can divide into root 40. If they're both under radicals, we can go ahead and divide them. Remember, we could split them up, we can also divide them. And because it goes into this 24, it can also divide into this root 24. So let's see what happens when I do that. 3, well, I need to take off my highlighter. Root 8 into root 40 is root 5. Well, that's convenient. Root 8 into root 24 is root 3. Well, that just made this question a whole lot easier. Don't forget with this negative root 5 standing alone, there is an invisible 1. So 3 minus 1 is 2 root 5 plus 2 root 3. Great job.